This is a photograph from 1944, and that's not a trick of the camera angle. The soldier standing next to this vehicle really is that small compared to it. This is the Mouse. At 188 tons, it remains, to this day, the heaviest fully enclosed armored fighting vehicle ever built by any nation in history. It's roughly 10 times heavier than a Sherman tank, and despite years of design work, resources, and steel poured into it in the middle of a losing war, it never fired a shot in anger. Not once. This is the story of Germany's biggest tank, and why building something enormous doesn't automatically make it good. To understand the Maus, you need to understand a pattern that shows up again and again in late war German weapons development. The belief that if a weapon isn't winning, the answer is to make a bigger version of it. By 1942, Germany's tank designers, along with Hitler himself, had become fixated on the idea of a true breakthrough tank, a vehicle so heavily armored that it would be effectively immune to enemy anti-tank guns at any practical range, capable of leading an assault and simply shrugging off whatever came back at it. This wasn't a totally irrational idea in isolation. Heavier armor genuinely does provide more protection. The problem was how far Germany was willing to take that logic. The project landed on the desk of Ferdinand Porsche, yes, that Porsche, the same engineer and company behind the car brand who had already been working on heavy tank designs. Porsche's team proposed a vehicle initially planned around 100 tons. By the time actual engineering constraints, armor requirements, and Hitler's own preferences got involved, that number kept climbing and climbing. Eventually, it landed at roughly 188 tons in its final combat-ready configuration. For context, that's heavier than 3 Tiger tanks combined. Almost immediately, the sheer scale of the Maus created engineering problems that had never really been solved before, because nobody had ever needed to solve them, nobody had built an armored vehicle anywhere close to this size. The armor alone was staggering, up to 240 millimeters thick on the front of the turret and around 200 millimeters on the hull front. For comparison, that's more than double the frontal armor of a Tiger tank. In theory, this made the Maus essentially invulnerable to any tank or anti-tank gun fielded by any nation in World War II from any realistic combat range. But armor that thick weighs an enormous amount, and that weight created a cascade of problems. No conventional tank engine could move 188 tons at a useful speed, so engineers had to install a massive 1,200 horsepower engine, originally designed for use in submarines just to get the thing moving at all. And even then, top speed was a sluggish 13 kilometers per hour on roads and considerably slower off-road. Then there was the bridge problem. Most bridges in Europe, built for vehicles a fraction of this weight, would simply collapse under a Maus. Germany's actual planned solution was almost comically extreme. Rather than building stronger bridges everywhere the tank might need to cross, engineers designed the Maus to be able to ford rivers by driving completely underwater, using a snorkel-like tube for the crew to breathe and for the engine to draw air. Picture a 188-ton steel coffin slowly crawling across a riverbed, completely submerged, while the crew inside hopes none of the seals fail. As if the armor weight wasn't enough of a challenge, the Maus was also designed to carry a genuinely massive main gun, a 128 millimeters cannon, roughly double the caliber of the gun on a standard Tiger tank, backed up by a smaller 75 millimeter secondary gun mounted coaxially in the same turret. This gun was so powerful that on paper, it could destroy literally any Allied or Soviet tank of the war at ranges where those enemy tanks couldn't even scratch the Maus's armor in return. In a pure one-on-one tank duel, fought on flat, open, structurally sound ground, the Maus would have been nearly unbeatable. But a turret capable of housing and traversing a gun that large, on a vehicle this heavy, needed its own dedicated electric traverse system, because manually rotating a turret carrying that much armor and gun weight was simply not physically practical for a crew to do by hand in any reasonable time. The tank essentially needed its own onboard power generation system just to aim its own weapon, another layer of mechanical complexity on top of everything else already straining under the vehicle's own weight. Here's the part of the story where all these individual problems collide into the reason you've probably never heard of a mouse actually fighting in a real battle. It couldn't cross most bridges, it moved barely faster than walking pace, and by the time prototypes were ready for testing, Germany's war situation had deteriorated to the point where building more of these enormous, resource-intensive vehicles made almost no strategic sense. Only 2 prototype hulls were ever completed, and only one of them ever received a working turret and armament. Hitler had originally wanted well over 100 of these built. In reality, Germany's industrial capacity, already stretched thin and increasingly disrupted by Allied bombing campaigns, could barely support finishing the handful of prototypes that existed, let alone mass production. There's also a strategic problem that goes beyond just manufacturing capacity. A 188-ton tank that can barely cross a river or a damaged road is enormously difficult to actually deploy usefully in the kind of mobile, fast-moving warfare that dominated the Eastern Front by 1944. Even if Germany had built 100 Mauses, getting them to a battlefield in a useful time frame over Europe's actual road and bridge infrastructure would have been its own nightmare separate from the tank's design. By early 1945, with Soviet forces closing in on the testing grounds where the prototypes were located, German engineers destroyed the incomplete second prototype to keep it from falling into Soviet hands, though the completed prototype was captured largely intact and eventually shipped to the Soviet Union for study. A few facts that tend to get skipped in the standard breakdown. Its name has a slightly awkward backstory. Maus means mouse in German, an almost sarcastic-sounding name for a 188-ton vehicle, though there's some debate among historians about whether it was meant as intentional irony, a security code name designed to sound unimportant, or simply an arbitrary designation that stuck. Either way, calling the heaviest tank ever built Maus has become one of those small historical details people love repeating. The crew literally couldn't escape through the top in an emergency the normal way. Due to the sheer thickness of the armor and hatch design, evacuating the tank quickly under combat conditions would have been significantly harder than in a standard tank, something crews of far lighter vehicles already struggled with when their tank was hit and on fire. It's still around today. The single, combined, mostly complete Maus, assembled by the Soviets after the war, using the hull from one prototype and the turret from the other, is on permanent display at the Kubinka Tank Museum near Moscow. It remains the only surviving example, and visitors can see, in person, exactly how absurdly oversized this thing really was, compared to any tank standing next to it. Porsche's team had already lost a heavy tank competition once before. The same design team had earlier lost the contract to build the Tiger tank to a competing design from Henschel. Some historians view the Maus, in part, as Porsche pursuing an even more extreme design in an attempt to secure a major heavy vehicle contract after that earlier loss, chasing a bigger prize after missing the first one. It's tempting to just call the Maus a complete waste of resources, and from a purely practical war-winning standpoint, that's not an unfair conclusion. Every ton of steel, every hour of skilled engineering labor, and every resource poured into these 2 prototypes came at a point in the war when Germany desperately needed simpler, cheaper, faster-to-build equipment in large numbers, not a handful of nearly unusable super-heavy prototypes. But it's also worth separating, was this a good wartime decision from, was this an impressive piece of engineering? Even critics of the project generally acknowledge that the Maus pushed armor, gun, and mobility engineering into genuinely unexplored territory. Some of what was learned about extremely heavy vehicle design, power transmission, and underwater fording systems had at least some influence on later post-war heavy vehicle engineering, even if the tank itself never proved anything in combat. In the end, the Maus is less a story about a weapon and more a story about a mindset, the assumption, common in the later years of Nazi Germany's war effort, that bigger, heavier, and more extreme was always the answer, even when the battlefield reality of 1,944 and 1,945 increasingly demanded exactly the opposite: smaller, faster, cheaper, and easier to build in large numbers. The Maus never destroyed a single enemy tank. It never even reached a real battlefield. But in a strange way, that might be the most interesting thing about it, a weapon built entirely around the idea of being unstoppable that ended up being stopped by something far more mundane than any enemy gun: gravity, bridges, and a country that ran out of time and resources before its most extreme idea could ever prove itself. If you want to see what happened when Germany went in the exact opposite direction, trying to build something small, cheap, and desperate near the very end of the war, let me know in the comments, because that story is just as strange as this one.